Hello Flat Earth researchers, debaters and debunkers. I'd just like to use this Cartesian diver here to show how gravity based on the mass of the Earth is a complete fallacy, and that we do not even need to consider how things get drawn to the Earth if we are not concerned whether we are on a spinning ball and we might fall off or get spun off. Everything depends on the density and pressure of the element that we are in. Here we have this little kid's toy that I've just made with the lid of a ballpoint pen, and the top is sealed off so that there is a bubble of air inside here making it float, and we have some plasticine or Play-Doh on there just to give it some weight. And all we need to do to make this lid go down in the water is to adjust the pressure of the medium it's in. So if I add some pressure to the bottle by squeezing it, what will happen is the lid goes down. Alright? Yeah? It wasn't suddenly affected by gravity, it was just a change in the pressure around it and the equilibrium of the two being put out of balance. So if I release the pressure again, it rises up. Okay, so it's all to do with the amount of space that the medium is taking up, its volume, and the volume of the air inside here, and the density of the different mediums and the object. Okay, so we can also make a new equilibrium where we have the lid kind of halfway. If I just adjust the pressure a little bit, we can keep it suspended there. Okay, alright, so of course this is by me artificially adjusting the density, because I've slightly reduced the volume that the water takes up and put it under more pressure. Okay, so the same thing happens in the air. This is what divers do when they add weights. Of course, they're putting compressed air on their backs, and that's making a difference in their natural buoyancy. So then they have to add weights around their waist, and their whole idea is not to sink to the bottom, but to create an equilibrium between, say, 1 and 30 or 40 meters of water, where before it gets more dense and there is more pressure on you. We all know that the deeper down in the water you get, the more pressure there is pushing down on you. And that's the same with the air. We are here on the ground, quite low to the ground, and the air pressure on us is quite extensive. It's quite a force that we all know, and maybe the higher up you get, the less pressure the actual air is putting on you. Same principle as this. You don't need to have the Earth being a certain mass and creating a force which pulls you down to the ground, because the pressure of the air at this level is already pushing us down. And the same with the water. The deeper down you go, the higher the pressure, and it's all about reaching an equilibrium.